body system से
So, good afternoon, everyone. We shall now resume proceedings with the concluding technical session of the day. So, good afternoon, everyone. We shall now resume the proceedings with the concluding technical session of the day. For this, I am pleased to introduce our next panel speaker of the day, Dr. Subhari Ghosh, who is currently an assistant professor in faculty in the Department of Computer Science and Engineering at Indian Institute of Information Technology, Bharatpur. He has obtained his PhD in CSE from NIT Durgapur, West Bengal. Previously, he has also completed his BTech in CSE from NIT Durgapur, West Bengal, India. His research interests cover the broad areas of ordinary-based processing, biomedical-based processing, multimodal AI, generative AI, and explainable AI. Dr. Ghosh has made notable research contributions with a total of 30 accepted research publications, including 11 journal papers and 19 accepted conference papers in the above areas. I now request Dr. Subhari Ghosh to kindly. Good afternoon, everyone.
screen visible है.
Is it visible to all the participants? I think it is visible. So let's start the today's concluding session. The topic of this session is intelligent agriculture, from AI fundamentals to deep learning driven precision farming. So in the previous lectures, some detailed in-depth advanced deep learning architecture as well as some application of biomedical engineering and agricultural engineering you have seen. But in this lecture, I will start from the fundamentals of the AI as well as some deep learning techniques, introducing the machine learning and deep learning, how it comes, and after that, their application in the agriculture domain. So this is the roadmap of my lecture today. First of all, the motivation of intelligent agriculture. So I can split my lecture in 6 sections. Firstly, the motivation of intelligent agriculture, why the AI-based agriculture is needed. That will be clear first. Then the fundamentals of AI and machine learning I will discuss. Then the introduction to deep learning, how it is coming, how to switch to the deep learning architecture. After that, the deep learning application of agriculture, then automated machine learning and neural architecture start, and finally the future direction in precision farming. So this is the roadmap of my lecture today. So first question is, why agriculture needs intelligent systems? Till now, some manual techniques are there. The farmers are working. We have some manual data, manual techniques, harvesting techniques. But why the intelligent system is needed? These are the main criteria for using the intelligent system for agriculture. Mostly climate variability, water scarcity, crop disease outbreak. Crop disease outbreak means there are multiple types of new diseases that are introduced right now. For different types of crops are there, and there are different types of diseases are there. So we need to classify them, we need to detect them. Similarly, soil degradation is there, yield uncertainty is there. There is a need for sustainable farming, and mostly the shortage of labor means if we want to analyze a huge amount of agricultural data, some manual, the number of manpower will be needed very high. So therefore, some intelligent system we must introduce. So these are the main motivation behind using the intelligent system for agriculture. So modern agriculture is evolving from experience-driven farming to data-driven intelligent decision system. So this is the difference between traditional versus intelligent farming. So generally in traditional farming, what we do, manual monitoring we do, and some uniform irrigation system we use. Similarly, some reactive disease control, human-on decision, these are the features of traditional farming. But if we introduce AI, intelligent system for farming, then we can get the advantage of AI-assisted monitoring as well as precision irrigation, predictive disease detection, data-driven decision, and real-time analytics. So mainly the precision agriculture means the right resource is there, right place is there, and we have the right time. So these are the data ecosystem of agriculture. So in which way we can get agricultural data? So mostly for enabling AI system or intelligence system, we need some data first. So AI data can be accessed through drone imagery, soil sensor, farm machinery, satellite data, and mobile application. So mostly the drone imagery is used. The drone are used for the agricultural field for capturing the photo image of the data. After that, some image processing technique we use to detect the disease or other purpose for agricultural ecosystem. So similarly, satellite data, sensor-based data, some IoT device we use for soil to take the sensor data. So, what is the role of AI in precision agriculture? So, where we can put the AI model in the agriculture. We have the agricultural data. We will use some pre-processing techniques. After that pre-processed data, we will feed it to the AI model for prediction and analysis. So mainly, the purpose of AI model is to predict the disease or analyze the huge volume of data and provide a decision support system. So mainly, the AI model is used to handle the pre-processed data for the purpose of prediction and analytics. So these are the application of AI in agriculture, mostly disease classification, different types of leaf disease we can classify, weed detection from the plant, we can detect the weed, smart irrigation, some so smart irrigation strategy we can introduce by using AI for agriculture, yield prediction to predict the crops. Similarly, crop monitoring, the status of crop throughout the year we can monitor through the AI-based system as well as autonomous farming. So these are the application of AI in agriculture. But the question arises, how AI will work for applying in the agricultural domain. So mostly, therefore we need to first learn what is AI and how AI is coming. So these are the mainly the motivation of AI. So to enable the intelligent farming, we must learn the pattern from AI, agricultural data. Therefore, we need AI. So this is the motivation. But what is AI and how it works? That basic background I will cover in the next page of my lecture. So is it clear up to this? The motivation behind using AI in agricultural domain. So I think now I am switched to the basic of AI and after that lesson learning. So the first question will come, what is AI? So AI is the process of building intelligent machines from vast volume of data that can think or mimic like a human. Why it is needed? Because we need to enhance the speed, precision and effectiveness. So AI basically use some complex algorithm to build machine to make decisions. So here is the vast volume of this data is there. The machine, the model will learn from data and it will build intelligent system. So it is a basic block diagram of AI. So these are the example of AI. I think how many have not used any of these today. So Face ID, Touch ID, similarly Google Maps, some social media recommendation systems, Netflix, Alexa, ChatGPT. I think all of you have used any of the applications today. So they are mostly the application of AI. So how AI is all around us, this question will come. So first of all, we will start from the some basic history of AI, who, when, and how it is developed. Mainly, right now, AI is the currently one of the hottest buzzwords in technology as part of our everyday life. So mainly the first question that Alan Turing has proposed, that I propose to consider one question: can machine think? Basically, Alan Turing can be called as the father of AI. So, firstly, he proposed this question to consider: can machine think? So, the answer is he want to think. We want the machine to think. Therefore, the question arises: can the machine think? And after that, how it can be, how the thinking can be. So these are the furthermore the development of AI. So John McCarthy is one of the founding father of AI, and together with Alan Turing, Marvin Minsky, and others. So McCarthy coined the term AI in 1995-55 and organized the famous Dartmouth Conference in the summer of 1956, where it is the first conference in the field of AI. So there are some notable person in the field of AI. Then the question will come: why AI? What is the necessity to mimic like human? What is the necessity to think like human? The most, the main cause is the data explosion. What is data? Then the question will come: what is data? Data is basically a set of records or described by some attributes and a class. Suppose in this classroom, too many students are there, so there are different attributes, different features are there for every student. We can assume it as a data. So data can be everywhere. Now we have a huge amount of data, large amount of data, some data exploration is there. And our goal is to learn a predictive model from the data to determine the classes of new instance. So data is the main backbone. Data is the new oil for bringing the AI topic, because data is the main. Data is the oil. If AI machine is the engine, AI model is the engine, then the oil is the fuel is the data. The good quality of data will be there. The good quality output of the model will generate. Like if you are using one vehicle, one engine-based vehicle where some petrol is needed, if the quality of petrol is very bad, then the longevity of the car will be bad. And if the quality of petrol, quality of fuel is well, then the longevity of the vehicle will be better. Similarly, the quality of data will be good, then the engine, the machine, the AI system will produce good output. If the quality of data is bad, then the system will produce bad output. So therefore we can tell that data is the new oil. So mainly data purpose, first of all, we need to acquire some data, we need to prepare the data, and after that we need to ready the data to feed to the model. So these are some the information like data that all human generated data up to 2003 is 5 exabytes, that is 1 million terabyte equal to 1 exabyte. So the same amount of data is generated every 2 days in 2011 and every 10 minutes now. Can you assume the huge amount of data we are generating every day? The amount of data in 2003, up to 2003, the total amount of data is there, and right now we are generating the same amount of data in every 10 minutes. So we can tell that data is like the crude oil. Why crude oil? We can directly use crude oil to the vehicle, to the engine, because crude oil must be refined fast. Similarly, if we have some raw data, can we use directly to the model? We cannot use the raw data to the model. We first make the data refine, we first make the data pre-processed. After that, we can use the data to the model. So data is like crude oil. It's valuable, but refining it fast. So one question, currently how much data is generated each day? Every day how much data we are generating? You will be astonished that every day we will create 2.5 quintillion byte of data every day. This is the amount, 2.5 quintillion byte of data every day we create, and 90% of world's data right now created in last 2 years alone. That means right now we are generating huge amount of data every day, and we need to process this huge amount of data. Our human brain cannot process this huge amount of data. Think like, suppose there are 5 poems is there, you have to recall it. You can capture it, you can recall it, the 5 poems. Max to max 10 poems you can recall. But if it is 1000 number of poems, you cannot recall it properly. Similarly, if the less amount of data is there, that time your brain can process. But when the number of data is this amount, the 2.5 quintillion bytes of data for each day, that time your brain, the human brain, cannot process this huge amount of data. Therefore, the necessity of AI, the necessity of intelligent system will come. So, one quotation that is very famous, that if the 20th century, the last century was about the computers, the current century is about the intelligent system. That means in the last century, some basic knowledge of computer will be was needed. In the last century, some basic knowledge of computer was needed, even if in banking sector and other railway sector, every sector, you are doing one job, one computer basic knowledge was needed in the last century. But right now, you have to acquire some knowledge of intelligent system or AI system. I think everyone using ChatGPT and other AI tools. So basic knowledge of using this intelligent system is right now needed for the current century. So this is, therefore it can be called that AI is the new electricity. So now I have told much about data. So there are two types of data is there. One is structured data, another one is unstructured data. So what is the difference? Structured data can be displayed over columns and rows, like database. What we created in Excel, some columns and rows are there. That is a relational database. Some numbers, some dates, the streams are there. This is the structured data. And unstructured data means it cannot be displayed in column or rows, like huge image data, speech data, audio data, signal data. That can be called as unstructured data. Similarly, right now the number of data we are generating, 20% of the enterprise data is structured data. Structured data generally requires less storage. So some Excel file is there, some rows and columns are there, some value, some numerical value, some categorical value is there. That is the structured data. But what I am telling, the audio, my face image, the video, the signal, the echo, these are the unstructured data. These cannot be processed like a Excel file or other things. So it acquired more number of storage to capture the unstructured data. So structured data is easier to manage as it is already structured in well form, but unstructured data, it is more difficult to manage and protect with legacy solution. So these two types of data is there. So I think it is clear that if we are having structured data, we can build the model very quickly, very faster. If we have unstructured data, we need to do some pre-processing and other steps to make the model, to fed the data into the model. So this is what I have told earlier. If data is the new oil, then machine learning and deep learning algorithms, I am coming to this point, machine learning and deep learning from the AI. So these are the new engines. So this is the main point, the data science versus artificial intelligence versus machine learning versus deep learning. So this Venn diagram, we all know the total is the data science, AI is the subset of data science. So what is data science? That extract deep insight from the raw data to make informed decisions. That is the data science. The whole universe is the data science. AI means a subset of data science. You can assume that these, suppose this classroom is the data science, then these 4 rows or 4 columns are the AI. AI enables machine to perform complex tasks. Machine learning, one subset of data science, like if these 4 columns are AI, then 2 columns will be machine learning. It creates a system for the computer to learn from the data and use the insight to improve their operation over time. And deep learning, it is also a smaller subset of machine learning that involves neural network to mimic human brain capability. So the whole world is the data science, AI is the subset, machine learning is furthermore subset, and after that deep learning, and after that some advanced artificial neural network and other neural network architecture will come. I will go step by step. So right now some AI introduction I have covered. So this is the AI versus machine learning versus deep learning, what I have told. So broad idea is AI. Example is Alexa answering question or ChatGPT answering question. Machine learning is subset of AI that learn from data, like Netflix predicting what to watch. Suppose you are searching one item in Google, suppose one item to buy, to purchase in Google, you can see after some days or after some hours in your Flipkart or in your YouTube as well or in your Facebook or other social media, the advertisement of similar type of product is coming. This is the recommendation system, that is the application of machine learning, that is predicting what to watch. And deep learning, it is a type of machine learning that uses neural network. Main motivation is it is the complex architecture, but it can handle huge amount of data very well. That is simple example is face recognition device in your mobile phone. So this is the basic difference between AI, ML and deep learning. Now I am coming in details. What is the machine learning? So machine learning is the study of algorithm that learn from data, example or sample and make prediction of new data. Here in the slide I have given one example of checker learning problem. What is the checker learning problem? One person, one human being is playing chess with the machine, the computer, the AI system. The Tom Mitchell, they defined this as the how, suppose you are playing your chess with the computer. So how the computer will work? You have given one move in the chess, he will give another move. You can do a blunder move or bad move, then he can capture your piece. If you give one good move in the computer, he will do another good move to avoid checkmates. So the system, the AI system or the computer on which you are playing the game, he will modify himself. The device will modify itself for restricting the checks and other things. The good you will play, he will play better. Similarly, the machine learning model works like this. It will improve its performances over time with experience. So, if the performance can be defined as P, task is defined as T, and experience is defined as E, then a learning task, a well-defined learning task is given by P, T, and E. So, mainly the experience you will gather, the machine learning model will gather the experience to do some task. It will improve your performance based on the previous experience what here or the model has done. So a computer program is said to learn from experience E with respect to some class of task T and performance measure T So if its performance as tasks in T as measured by P improves with the experience E. That means the time, the task and the performance that will affect the experience, right? So this is the similarly the machine learning model will work. It will take some time to learn. It will gather some experience. It will generate good performance. It will give good performance based on the previous experience and previous task. So this is the machine learning process. This is the flow chart. First of all, the data provider will give you some raw data, what I have told, the crude oil, the raw data. The raw data will be pre-processed. So how the pre-processing is done? There are several steps that they are like augmentation, normalization, and other things. So pre-processing is done. The iteration will be done until the data is prepared for feeding into the machine. After that, some learning algorithm, that is the machine learning algorithm, will be there, and after that, selected model will be deployed and application of the model. That means from the data, some output will be given. So this is the simple workflow of the machine learning process. So I think some basic of AI and machine learning is clear till now. So now I am going to the different types of machine learning models, the categories of machine learning models. So basically three types of machine learning models we can assume: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning means it is task driven. It predicts the next value. That is learning with labeled data. Supervised learning works with labeled data. Unsupervised learning works with unlabeled data. So what is labeling? What is data labeling? That is the important. So if you are having the labeled data, you will employ supervised algorithm. If you are having the unlabeled data, you will employ the unsupervised algorithm. And reinforcement learning, it basically learns based on the feedback or reward. Suppose you have done a good work, I will give you some reward. If you have done some bad work, I will give you some penalty. So based on the reward and penalty, the model will learn the feedback or reward you will get. If the reward is good, if the number of reward, the amount of reward is very good, then he will follow this path. If the penalty is good, means reward is less, that time it will not follow this path. So this is the learning from the feedback, learning from its reward. So it is called reinforcement learning. So these three types of categories of machine learning models are there. So I will go each example of the each models. So this is the supervised learning. What I have told, learns from label data. So what is label data? See in the blue box, some shapes are there: hexagon, triangle, and square. That means these are the label data. That's why, because you know this is the hexagon, it is labeled. This is the triangle, it is labeled, and this is the square, this is labeled. That means you know the data, the labeling is done. That time you will train the model by using supervised, and you will do some prediction whether if the single sample is shown to you, whether it is square or it is triangle or it is hexagon. So this is the supervised learning algorithm. Here you are having the labeled data. You want to make prediction, you want to make some classification. That time you will use supervised algorithm. In this example, some shapes are there: hexagon, triangle, and square. You want to classify them. That time you will use the supervised learning algorithm. And basically two types of supervised algorithm is there. One is classification, one is regression. So I think from the name you can identify what is classification, what is regression. Classification means you are having 5 types of samples, you want to classify them based on any criteria. Regression means you want to predict something, like weather prediction. That is the regression problem. But you are classifying different types of fruits from a bucket. That is the classification problem. So these are the supervised and supervised learning types. So this is the classification problem. the spam detector in email. A mail is received, whether it is spam or it will go to the inbox. That is the supervised learning algorithm, the classification problem. Sentiment analysis, or this image, it is cat or it is dog. This is the classification. And regression means you want to predict the continuous value from the level data. That is weather forecasting or academic performance prediction based on the experience. These are the regression problems. Now, unsupervised learning, what I have told, if you don't have any level data, some unleveled data is there. That time you have to find the hidden structure. Then that time you have to use unsupervised learning. Basically, the common techniques are clustering and dynamic reduction. So, dimensional reduction. So, these are the example of unsupervised learning. This is the clustering. Clustering means the closest region objects will be clustered together. So this is the clustering. So this is the technique for handling the unleveled data. Some unsupervised learning will be there. Now, example of unsupervised learning, grouping of elements. Suppose you are having raw data. You don't know which is apple, which is banana, which is mango. The raw data is there, no labeling is done. That time you want to make a model to predict what is apple, what is banana, what is mango. That time you will use unsupervised learning algorithm. Similarly, customer segmentation. In the target market, different types of customers is coming, different types of different people is coming. You want to segment like this: some satisfied customer or unsatisfied customer, quietly satisfied customer. That time you will use unsupervised learning algorithm. Or news categorization means you are having different types of news. Maybe it's social news, relational news, music related, lifestyle related, sports related, education related. You want to categorize them. That time you will use unsupervised learning algorithm. And reinforcement learning, what I have told you, one agent will be there. Agent will interact with the environment. It will get some reward or penalty. It will update itself, and after that new action will be done. Suppose, very simple example, see myself like an agent and you are the environment in the classroom. So you are the environment, I am interacting with you. I am the agent. I am giving one lecture to you. Now you are telling that it is very good. The lecture is good. That means you are giving some reward to me. I will update myself in the next lecture when I will give that this type of lecture I have to handle because I have got some reward from you. I have got some reward from the environment. But if you give some feedback that my lecture is not good, I have to improve in these fields. That time some penalty will be imposed to me, the reward will be less. So from this experience, in the next lecture, I will modify my tone and modify my slides as well. Because last time I have got some negative impact, negative reward. Similarly, when agent interacts with environment, two possibilities can be assumed. One is rewards, another one is penalty. And after interaction, based on the reward or penalty, the agent will modify, agent will update itself. This is called reinforcement learning. So this is the examples of reinforcement learning. Where can it be done? Teaching a robot to walk, self-driving car navigating a road, game playing board. Suppose you need to you are teaching a robot to walk means, suppose the robot is coming in this room, he will enter through the door, then he will go to the corridor. Suppose after entering into the room, the robot wants to go straight right. He will first oblige by the bed, by the table. That means he will get some negative reward. If it is obliged by the table, that means he will not follow that path in the next step. He will find what is the best path to go to the last. So he will find the corridor because he will get the reward if he go through the corridor, not through the bench. Similarly, self-driving car, it always wants to avoid the accident. If the any path he can see that accident can be done, he will not choose that path. Similarly, game playing bots are there. He always wants to improve the performance. This is the example of reinforcement learning. Some intelligent vehicle, what I have told, the example of reinforcement learning. So these are the machine learning algorithm taxonomy, supervised and unsupervised. Supervised have two things I have told, classification and regression. Different types of classification algorithms are there. Support vector machine, decision tree, random forest, that can be addressed in details in further. And regression problem, linear regression, some neural network based regression, support vector regression can be done. For clustering, different techniques are there, k-means clustering, mean shift clustering, and for reinforcement learning, Q learning, R learning, similar types of decision making learning problem is there. So these are the just taxonomy of algorithm, some name of algorithm I have mentioned. I will put details on this because our lecture is over the application in agriculture. So these basic things is needed for machine learning for your next step. So now when to use what? So I think it is clear right now to you. You have labeled data, one prediction, supervised learning, unlabeled data, one pattern discovery, then unsupervised learning, and interactive tasks with rewards, then reinforcement learning. I think it is clear to you. So now same example what I have told you. So machine learning, when you need the supervised classification problem, mainly identify fraud detection, image classification, customer retention, diagnostic purpose, etc. Regression, weather forecasting, market forecasting, estimating life expectancy, population growth prediction, etc. You will use unsupervised learning for clustering and dimensionality reduction, what I have told, and reinforcement learning for real-time decision and learning tasks. So now, machine learning versus deep learning. Till now, I was in the machine learning phase. Now, where the deep learning is coming, why it is called deep learning, that is our next focus in our lecture. So, deep learning is the subset of machine learning, what I have told. Main thing is it uses multiple layers for learning data representation. Mainly, example is there. See, in machine learning model, the input card is there. The feature is extracted by some handcraft manner, or physically the human interaction will be there for feature extraction. After that, machine learning model will be used and it will predict whether it is card or not card. In deep learning, inside the model, several layers, several hidden layers and hidden neurons will be there that will do the automated feature extraction and classification together. So feature extraction means everyone among us have some different features. What is the feature of mine? One blue shirt, one glass, one watch in my hand. These are my features. Similarly, if there are 50 people, different types of features are there. In deep learning model, this feature extraction is done automatically inside the model, and classification task will also be done inside the model. So this is the basic difference between machine learning and deep learning. In machine learning, we need to extract the feature, human intervention will be there, and after that classification model works. In deep learning, feature extraction and classification, that will work together. So deep learning will be beneficial when the large amount of data, huge amount of data will be there, because that time human intervened feature extraction will be difficult for us. So this is the difference between machine learning and deep learning. Now this is the how deep learning works. Deep learning applies multi-layer process for learning rich hierarchical feature. So what is rich feature? What is hierarchical feature? That you must know. So see this image of house. One room of the house is there. Low level feature means this type of representation. Some black and white representation. Mid level feature means this type of pattern. And high level feature means the object detection. So when we are using machine learning method, that time some low level features can be extracted by human intervention very well, but high level feature can't be extracted by human well. Similarly, the vice versa can be done, but in deep learning, it will together extract low level, different types of, different levels of feature, like low level, mid level, high level features. The hierarchical feature it will extract, and after that, one trainable classifier will be there inside the model, and it will predict the output. So this is the architecture of the deep learning model. Now the question arises, why deep learning is useful? I have already answered one part. Manually designed features are often over-specified, incomplete, and taken long time to design or extracting the feature. But deep learning provides a flexible, learnable framework for representing text, visual, and linguistic information. Means complex data is there. That time the feature extraction must be done automated. That time the deep learning will be useful, because deep learning can learn both supervised and unsupervised parts. Deep learning can utilize large amount of training data. Structured, unstructured, both type of data can be handled. All is the example of usefulness of deep learning. So the L03 mentioned in 2010 that the analogy to deep learning is that the rocket engine is the deep learning models, and fuel is the huge amount of data we can feed to this algorithm. That means the huge amount of data day by day we are providing, we are preparing, we are generating, we must handle them. The huge amount of fuel, we must handle them. Therefore, some rocket engine will be needed. The deep learning is this type of rocket engine. Therefore, to handle the huge amount of data, we need deep learning algorithms. So I think the motivation of deep learning is clear. Now this is the foundation of deep learning, the neural network. I think all of you are familiar with the term neural network. But why the neural word is coming? Neuron. The biological neuron is there in every human and every bird. So from the experience and from the resembling of the neuron, the artificial neural network models are generated. So basically in neuron, some parts are there. These are called dendrites, and some action is there, and some synapses is there. Neuron, what neuron do in human? Suppose a mosquito is biting in your hand. The signal will pass to your brain that the mosquito is biting. This signal passing is done by the neuron. In your body, several neurons are there, the thousands, the millions of neurons are there. From your hand to your brain, the neuron will circulate the message that the mosquito is biting. Similarly, the circulation of neuron is done through the dendrites and synapses. It is a neuron. After that, another neuron will be there. So the message will be, the signal will be passed from one neuron to another neuron. Similarly, the artificial neural network, different types of layers it uses. That is, therefore, it is called neural network. It is neurologically inspired mathematical model. And a large number of interconnected processing elements is there inside the neural network, just like human neuron, biological neuron. Huge number of processing elements are there. The connections are the knowledge, and it has the ability to learn, recall, and generalize from the training data. So therefore, the neural network term, the coining of the neural network is coming, and the artificial neural network are parallel distributed processing model, mainly connection based model, self-organizing system, and neurocomputing systems. So this is the foundation of deep learning architecture, the artificial neural network. So this is the deep neural network. This is the input, one image is there. First layer is the input layer. It will extract the features from the input. After that, multiple hidden layers will be there. The number of hidden layers may vary. The hidden layer will process the hierarchical features. Hierarchical feature means some low level feature may be there, some mid level feature may be there, some high level feature may be there. So different level feature will be there. So hierarchical feature must be processed through the multiple number of hidden layers. And after that, one output layer will be there. That the task of the output layer is to identify the combination of the features. So the main component of the DNN, the deep neural network, is models of neurons, the processing element, what I have told, the interconnection and the structure, and some training rules. This is vital. Training rules. The training rules will affect the performance of the deep neural network. Suppose you can assume an example of learning of a baby, a 2-year, 3-year baby. He don't know what is cow, what is cat, what is dog. You first want to familiar him. If you have a 2-year-old baby, first you show him an image of a cat and you tell that it is a cat. You show an image of cow, you tell that it is a cow. You show him an image of dog, you tell him that it is a dog. After repeated training, after repeated time showing, he can be familiar that he can correctly recognize that a cow as a cow, a dog as a dog. Similarly, the rule of training, the learning rule, will affect the performance of deep neural network as well. So this is the learning strategy. This is the processing element neuron. What works inside the processing element? Some weight and bias. These two terms is very difficult for deep learning. When the message is passing, for every step, some weight will be added and some bias will be added. And after that, one activation function will be there. I will go in details. So activation function will be there, and after that, output will be generated. So what is the activation function? Activation function is the part of the deep neural network model that helps the network to learn the complex pattern in the data. So neural network are having large number of layers, what I have told, multiple hidden layers are there, and it can assume complex functions. So non-linear activation function is there. See, in this example, different types of hidden layers are there, different weights are there, different biases are there, and we use the activation layer, the non-linear activation layer, for learning the complex representation. So ReLU, rectified linear unit, it is the type of activation function that takes real valued number, and threshold it as 0. So this is the equation of ReLU, and most of the modern deep neural network we use the ReLU based activation function because it is fast to compute compared to the sigmoid activation function, and it accelerates the convergence of gradient descent due to linear non-saturating form. So this is the type of activation function. Now the connections, what I have told, different types of neural network connections can be made. One is single layer feed-forward network. See, first example is single layer feed-forward network. Means one input layer is there, one output layer is there. Similarly, the third example is multi-layer feed-forward network. Means multiple hidden layers are there. The second example is note how the message is passing. This is the recurrent network. Recurrent network means after passing the message, it will recall the previous input as well. The message will be back propagated again. It is the single layer recurrent network. Similarly, it is the multi-layer recurrent network. So these type of different connection and structures are familiar. You have to familiar while you are using the deep learning algorithms. So this is the training on learning the neural network. What I have told, some parameter learning is there. Parameter learning means you have the weight is there. You have to learn. You have to update the connection weight based on the necessity. And structure learning, that means you have to change the structure of the neural network. That means hyperparameter, that is one point, one thing will come in after this part, basic deep learning part. I will also discuss about the hyperparameter and other things. So this is the general weight learning rule of simple neural network model. Now the convolutional neural network, it is an advanced type of neural network, CNN. We have all heard the term CNN, and we have also somewhere used it, but we must, if I want to go to the fundamental part of CNN, then it is basically a neural network with some convolutional layer. So what is convolutional layer? A layer, some convolution operation will be made inside the layer. So in CNN is a neural network with sharp convolutional layer, and the layer has a number of filters that does the convolution operation. So I am showing you example. Suppose it is a color image, the RGB image, the three channels are there. When you are extracting the feature from the colored image, it will convert it in some 01 form. And if you use some filters like this is the first round of filter, it is the second round of filter, then you can get this type of convolution operation. This type of convolution operation can be done inside the CNN model. So this is the convolution and this is the fully connected. The comparison is there. I think all of you know the convolution operation. So now the whole CNN, the image of cat is there. You perform the convolution operation. Then max pooling, one term. In the next slide, I will discuss about this. Max pooling will be there. So convolution and pooling, these can be repeated, differ many times, several times. After that, flattened layer will be flattened vector will be there, and after fully connected feed-forward network, the classification will be made as whether it is cat or dog. So this is the whole CNN. Then the first question is, what is max pooling? Why pooling? So subsampling pixel will not change the object. Suppose this is the total bird. I think. Yeah. So this is the bird. Subsampling means the lower dimensional bird. We don't want to compromise with the features of the bird. Means the color of the bird is blue. Here also blue. The bird has an eye, one beak, eye and one beak also same. We have just compromised with the size. We have just compromised with the aspect ratio. But we have not changed the object. We have not covered the. We have not changed the features of the bird. So we can subsample the pixels as well to make the image smaller, because if we are having fewer parameters to characterize the image, we can do this. If we are having some fewer criteria to recall anything, we will do the fewer things. Similarly, this is the high number of parameters are there. We need to do some subsampling to make it lower dimensional, fewer parameters. That time subsampling is needed. That is the need of the pooling layer. Therefore, the pooling is there. Suppose it is a 6x6 image, the 6:6 image vector. After the convolutional layer, if we use the max pooling, we can convert it into a 2x2 image. This is the necessity of the max pooling layer. We will do the convolution operation and the pooling till and until our goal is achieved. So after the max pooling, we will get the new image but smaller image. That is the necessity of the max pooling layer. Now the whole CNN, the convolution and max pooling, we will repeat it over times. We will get the new image every time when we apply the convolution and the pooling layer. After the image, the new generated image will be smaller image than the image, original image. And after the several rounds of convolution and max pooling layer, the number of channels, the number of filters will be changed, and we will get the lower dimensional image. That time we can apply the flattened vector and the feed-forward network. So now the convolution and max pooling is clear. The generation of new image, lower dimensional image is clear. Now the flattened vector. What is flattening? Flattening means, suppose you are having this image. If you are having this image, flattening means it will convert it into the one-dimensional array. So when you have used the convolution and max pooling operation several times, you have already reduced the dimension. After that, you are applying the flattening, the flattened vector, the one-dimensional vector you will get. That time, it will be easier to classify. From the complex structure, you cannot classify it. After the flattening, it is easier to classify. It is easier to apply the feed-forward neural network and fully connected neural network for the classification, whether what is 0, what is 3, what is -1, what is 1. So this is the background of CNN. By this way, CNN works. So these are some emerging AI and deep learning models. The convolutional neural network, what I have told, the CNN for the computer vision means image-based task. Similarly, recurrent neural network (RNN), that is one of the another emerging deep learning model, mainly used for time series prediction. UNet architecture, that is basically used for image segmentation. Image segmentation means from a big image you want to take or you want to consider a small fragment of image. From the whole, suppose from the whole blackboard, you want to classify this only this amount of data. That time it is called image segmentation. So UNet architecture, this is the another emerging advanced architecture, and also generative adversarial network for synthesizing image. That means it is the application of generative AI. Generative AI means you want to generate some synthetic things. Right now, ChatGPT and other things can generate things, generate images. Similarly, audio and video and other things you can generate. For the generative AI purpose, the GAN, the generative adversarial network, be used. So these are some emerging AI and deep learning models. So this is the example, the comparison of AI model versus machine learning model versus deep learning model. What I have told, the AI model based on certain data set through which it can arrive at a decision. Machine learning model, it is a kind of AI model that use mathematical formula. Deep learning model, that is basically a neural network model to train and learn how to perform a task. Basically for recognizing object or high data, high huge amount of data is needed. So this is the difference. So now the value of the AI model. So I think it is clear to you somewhat that how to use the AI model. First of all, collect the data. Secondly, use the AI model to generate the new data. After that, use the AI model to understanding the data and also to automate tasks. So these are the value of the AI model. Data is being generated as well for the AI model. So this is the AI role of AI and machine learning for engineering. So enhance efficiency and productivity, the good data analysis and decision making, intelligent systems and automation, predictive modeling and simulation. These are the role of AI and machine learning in engineering. Now we will go to our part, the agriculture. So deep learning for agricultural analytics. In the first page, we have learned the motivation of AI for using in the agriculture domain. Next, we have done the basic fundamentals and foundation of AI, machine learning and deep learning. Now we will go the deep learning for the agricultural analytics. So from the feature learning, what I have told, automated feature learning to intelligent crop understanding. So main motivation, main purpose, crop disease detection, drone-based monitoring, data-driven insights, and precision farming. So deep learning basically enables machines to automatically learn complex agricultural patterns from large-scale visual and sensor data. That is the deep learning for agricultural analytics. So why deep learning will be needed for agriculture? I think you all know the agricultural challenges are there. First of all, complex visual patterns are there. I think the challenges of agriculture includes the complex visual patterns, the large-scale image data, environmental variability is there, disease similarity is there, real-time monitoring requirement is there. This cannot be done by human intervention. Therefore, deep learning will help. Deep learning will help in automatic feature extraction, learning hierarchical representation, handling complex patterns of the image, scalable to large dataset and high classification accuracy. In this topic, in this point, deep learning will help to handle the agricultural challenges. So, this is the typical deep learning workflow. Mainly the agriculture data is there, leaf image, drone image or IoT based sensor image, weather data, soil data, these are the agricultural data. After that we need to pre-process. Pre-processing includes the augmentation, resize, normalization, splitting, in training, testing, etc. After pre-processing the agricultural data, we will use the deep learning model, CNN or any type of hybrid deep learning model. We will do the prediction and analysis, that is the feature learning, prediction, performance evaluation as well, and the decision support. the disease reduction or fertilizer management or smart irrigation and other things, smart farming, etc. This is the our outcome. Our goal is improve yield, reduce the loss of the crops and sustainable agriculture. So this is the workflow of the typical deep learning based agriculture model. So this is the CNN based crop detection model. One architectural pipeline I have shown. In your input image, one leaf image is there. Input leaf image is there. Suppose this is the diseased image. The image, the crop is having some certain disease. The leaf image is there. The RGB image, the some dimensions are there. We will use the CNN model. First of all, the convolutional block, and after that some pooling layer. What I have told, in the convolutional layer and pooling layer, it will reduce the dimension from this dimension to this. By number of convolutional blocks and pooling layer, we will get some low dimension features. After the low dimension features, we will use the flattened vector. After that, we use the fully connected layer, and after we will use some activation function and we will predict the disease, the class of the disease. Whether it is healthy, it is early blight, it is late blight, or any other disease the leaf is having. So inside one convolutional block, what is there? Input feature map is there. Feature map means when the system, the computer, the deep learning model is processing the image, when the deep learning model is processing the leaf image, it is not processing the image as its whole. It first convert it in the some mathematical form, some 0-1 form. That is the input feature map. After that, the convolutional filter is there. Then batch normalization, ReLU activation, other things will be there. That will be inside one convolutional block. That is the blue block. Okay. And after that, CNN operation will be there, and some constant, the hyperparameter we must fix. That is the input image size, filter size, pooling, dropout rate, learning rate, optimizer. These are the hyperparameters. Okay. So feature learning hierarchy. So now how CNN understands the agricultural image? CNN first need to understand the image. How it will understand? The image will have some certain pixels. From the pixels, it will understand the edges. From the edges, some texture it will understand. Then it will try to understand the pattern of the disease like yellowing, nascence, fungal spread, texture deformation, etc. Then it will get some leaf level understanding. So from the raw image, it will take some pixel, edges, texture. After that, it will identify the disease pattern. After that, it can understand the leaf level feature. So agricultural computer vision, mainly the application of image processing is there. Healthy versus disease, that is the image classification. Fruit counting, the number of fruits is there, that is the image detection. And image segmentation, the crop versus weight, that is the image segmentation. Basically three applications: classification, detection and segmentation, the agricultural computer vision are having. So, but what are the challenges of agricultural image analysis? Mainly the region specific patterns. Secondly, similar disease symptoms. Thirdly, some background clutters, illumination variation and environment variability. These are the challenges while analyzing the agricultural image. I think all of you can relate this while you are having a picture or an image photo of any crop. These type of challenge you can face, the background clutter or illumination variation or similar type of disease having same symptom, that can be done, or region specific pattern. These are the challenges of agricultural image analysis. So the challenges that cannot be learned, cannot be detected by CNN, that time we need to introduce some advanced deep learning model. So now next our part is toward advanced deep learning model. So CNN focus strongly on local features. However, agriculture often contains distributed or global disease patterns, and this motivates the use of vision transformer, the advanced deep learning model that are capable of learning long-range dependencies and global contextual relationship. So now some terms are coming, local features and global features. By a simple example, I can tell you that suppose an image of cat is drawn in the blackboard. In the board, an image of cat is there. CNN will detect it as it is a cat. But suppose the two eyes of the cat is there, the tail of the cat is here, the nose of the cat is here, the face of the cat is here. That time also CNN will detect it as a cat. Why? Because CNN will analyze each feature only, whether the two eyes are present, whether the nose are present, whether the tails are present. There may be the location, the orientation anywhere, but CNN will also detect it as a cat. But we need to detect that it is not a cat because it is the fragmented eyes, fragmented tails, fragmented nose, fragmented mouth. So that time we need to consider not only the local feature, we have to consider the global feature. That means the position vector, the orientational features and other things. This part CNN fails. That time we need to introduce transformer that will consider the global feature as well as the local feature. So this is called, so here in our slides, in our presentation, we will show the application of vision transformer based model. So vision transformer in smart agriculture. So basically the goal is to learn global context for intelligent agriculture understanding. And without global context learning, the main fundamentals of vision transformer is cell patterns and mechanism, some image patching approach, and better performance, providing better performance. So main feature is some cell patterns and mechanism and other thing, the patching of the image. This part will be considered covered by the vision transformer while we are using it in the smart agriculture. So this is the introduction to VIT. VIT process the images as patches, and each patch acts like a token. Patch means one row type or one column type things. Okay, so from the raw image, it will process the image as patches. After that, each patch will act like a token. Token means one. Suppose in natural language processing, some text data, a token can be considered as a word. Similarly, here in image, each patch can be considered like a token. So this is the architecture of vision transformer. Some transformer encoder will be there, some MLP head will be there, and some embedded patches will be passed through the multi-head attention and other architecture will be there. So this is the advantage of VIT. What I have told, instead of analyzing the entire image directly, VIT divide the image into the smaller patches and enable the model to learn the relationship among the patches. So the VIT can detect the cat, whether the two noses here, the tail is here, the face is here. The VIT will detect that it is not a cat. It is the fragmented eyes, fragmented nose, fragmented mouth. So this is the advantage of VIT. So the benefit is global feature learning, long range dependency modeling, better contextual understanding, and strong scalability. So it is the CNN versus VIT. The common CNN architecture, what I have told, it will be processed. Suppose the image of eye will be processed, and it will consider the different types of convolution operations and other things, the CNN architecture. But for VIT, the face image, it will be fragmented in several patches, and it will consider the relationship among each patch while processing the face image. So this is the difference between CNN and VIT. CNN that detect the localized lesion, VIT that detect the distributed disease pattern. So for the agricultural field, for the smart agriculture, the vision transformer will be better rather than the CNN. So this is the significance of VIT for agriculture: robust contextual understanding, better scalability, support complex agricultural imagery, enables intelligent automation, and facilitate advanced precision farming. So it can be represented as a major step forward toward the context-aware intelligent agricultural system. So this is the significance of VIT of agriculture. So I think why deep learning for agriculture and how deep learning can be employed for agriculture and the advanced deep learning models, it is clear to you. Now, one more research direction I will go, and that is the towards automated intelligence. So, as AI architectures become increasingly complex, manually designing AI model is also difficult. Right now, I am telling about manual feature extraction. That is difficult. Therefore, we are using AI model. The manual classification is difficult. Manually handling huge amount of data is difficult. Therefore, we are using AI model. But the quality of data, the complexity of data is very huge. In that case, manually designing the AI model is also difficult. So, manually designing the optimal model, it is a very difficult task, and it motivates the scientists to the need to intelligent optimization. That is the new direction of our research. That is the auto ML, the automated machine learning. That means automatically designing the machine learning or deep learning model. So, optimized model. So, what is optimization? I think all of you know. Optimization can be considered as minimization or maximization problem. That means optimization is a process for selecting the best solution from a set of feasible solutions. Right? If you need minimized solution, minimization problem, maximized solution, maximization problem. So different types of example is there optimization, minimizing travel cost, maximizing productivity, finding the shortest path. This is the optimization. So for the machine learning or deep learning also, why optimization is needed? The model parameters are there, the weight, bias, etc. Model hyperparameters are there, the number of layers, kernel size, stride, the number of neuron in each layer, and as well as the model design. While we are choosing CNN, or if we are choosing CNN, how many convolutional layers or how many pooling layers we will use. We need to optimize this also. This is the necessity, this is the motivation for using the automated machine learning, the optimized machine learning. So hyperparameter tuning. So hyperparameter basically set initially before training and not updated during training. And parameter, it updates itself while training. So when the training is going on, parameter is updating itself, but the hyperparameter is fixed. So hyperparameter we need to fix before the training is started. So the most common hyperparameter means number of layers, initial learning rate, decay, optimizer type, activation function, loss function. These things we need to mention before training. So when we have made a AI model, we need to train the AI model. Before training, we need to fix it. These hyperparameter values. So this is huge time consuming to find the optimal number of layers manually. To set the initial learning rate as optimal, it is not possible. Therefore, automated tuning of hyperparameter is needed. That is the motivation for using AutoML. So now the comparison between automated system versus AutoML. Automated system means a process or a set of process that perform tasks with minimal human intervention or no human intervention. That is the automated system. Example, self-driving car. This is the automated system. But AutoML, the process of automatically building the machine learning model. The process of automating the development of machine learning model. The different types of example is there, the Google AutoML, Azure machine learning, etc. has there. So this is the difference between automated system with the AutoML. So basically, automated system is a general process, and task automation is there. Basically rule-based or fixed algorithms are there. But for AutoML, it focused on machine learning model creation, and it is AI driven, fully AI driven, and it relies on the data and learning. So human involvement is minimal in automated system, but AutoML, some initial human intervention is needed. So are they overlap? Yes. Some cases, automated system may leverage AutoML to improve its performance. For example, a predictive maintenance system may use AutoML to create machine learning model for its own prediction. So this is the AutoML. What is AutoML? The computer programming. Here one funny image is there. After that automation is there. After that machine learning is there. After that AutoML is there. That means computer programming automates one thing. Machine learning, it automates the automation, and AutoML, it automates the machine learning. Means programming relieve people by managing routine tasks. Machine learning, it allows computer to learn to best perform such tasks. And AutoML, it builds machine learning model to help the computer to learn how to optimize the outcome. So, if the computer programming, we need the automation. For automation, we need machine learning, and for machine learning, we need automated machine learning if you want to configure it the machine learning model. So, the AutoML refers to the automating the end-to-end process of applying machine learning to the real-world problem. So, what are in the traditional ML? Before going to the AutoML, key steps of traditional machine learning is data collection, feature engineering, model selection, hyperparameter tuning, model training, validation, model evaluation and deployment. But the challenges in traditional ML is there. It is time consuming, it requires expertise, it is subject to the human error. But when you are using the AutoML, the efficiency will be better because human intervented error will not be there. Streamlines the machine learning water flow. It scalable solution it can produce. The productivity, the free up resources, allowing the experts to focus on more innovative tasks. So this is the importance of AutoML in engineering. So the main benefits of AutoML, the skill gap it will cover, the time constraints it will cover, the cost efficiency it will cover, the automation and exploration it will cover. So this is the justification of adopting AutoML in engineering related scenarios. So in our domain, so before going to the agricultural application, these are the components of AutoML. The data pre-processing. Data pre-processing includes data cleaning and data augmentation. Feature engineering includes feature selection, feature extraction. Model selection means algorithm selection, neural architecture search, and ensemble method, and hyperparameter tuning, the search method, and model evaluation. This from data pre-processing to evaluation part, it can be automated. This can be the components of AutoML. So this is the workflow of AutoML. Data acquisition, after that, the data exploration, data pre-processing, model selection, hyperparameter tuning. This part we can do by using the AutoML. The architecture search part that will motivate search us further for neural architecture search. So this is the workflow of AutoML. So this is the application of AutoML what I have covered. Environmental engineering, robotics, energy sector, everywhere the application is there where we are using the AI. So now the question is, why AutoML for smart agriculture? So AI-based agriculture we are having. What is the challenges in AI-based agriculture? The large variability of across the crops. The large variability across the crops are there. Different crops are there, different environments are there, and growth stages are different. The disease pattern that comes region specific. Limited AI expertise in rural deployment. The hyperparameter complexity tuning is complex, and the scalable intelligence system we need. So these are the challenges of using the AI in the field of agriculture in a certain village or rural area. Here AutoML will work. AutoML will automate the AI for smarter farming. AutoML will automate the model optimization. AutoML will reduce the human intervention. It will faster deployment, improve scalability, and better model generalization. So the basically human-centric AI, the agricultural AI that needs the human intervention, that are having certain challenges, certain limitations. If we are using AutoML, the automated machine learning, that time it will be beneficial for us for smarter farming in the rural area, in the also in the non-privileged area. So this is the manual AI model design challenges. What I have mentioned before, expertise requirement is there, that is not possible in rural area or village area. Trial and error. When we are deploying AI model, it is not possible for us to go for the trial and error. Means this is the optimal architecture. After that, you are adding one more layer. After that, you are adding one more layer. This trial and error, it is highly time consuming. Overfitting concerns can be there. The search space, architectural search space, that can be hampered, as well as hyperparameter tuning. This is the difficult. So, even for a single task, there is a huge variation of DNA, deep neural network architecture is there. So, this is the very time consuming and very difficult for manual designing the AI model. Here the AutoML comes, the neural architecture search comes. Neural architecture search means automatically design the architecture of the certain machine learning or deep learning model. So hyperparameter tuning as well as structure tuning. How many layers will be there? How many convolutional layers will be there in the CNN model? How many pooling layers will be there? How many feed-forward neural network will be there? Similarly, for vision transformer, how many patch embeddings we have to use? Right? How many transformer encoder we have to use? That is called neural architecture search. This is the one promising direction of AutoML. So this is the NAS framework. Briefly we can cover it. Search space will be there. From the search space, search strategy will be there. The methodology to utilize the search space, that is the search strategy. And from the search strategy, we will evaluate the best performance for the best neural architecture with the minimum cost. So this is the basic framework of NAS. So why the NAS is used? How the NAS will be used in agriculture? First of all, we are having agricultural data set. Agricultural data set means leaf image, drone image, satellite data, IoT sensor data, anyone. We will define the search space. That search space means type of model, which model we will consider, the number of layers, the number of heads, patch size, MLP ratio, etc. Then the optimization, NAS optimization, that can be defined optimization algorithm we can use. We can use evolutionary algorithm, reinforcement algorithm, or gradient based search. Some candidate AI model will be there, different architecture. After that, performance evaluation we will do, and after that we will extract the optimal agricultural model. This is the NAS, use of NAS in agriculture. So the main objective is to high classification accuracy, the computational efficiency, less human intervention, model robustness, and better generalization across different types of crops. So application safe. So this is the neural architecture search in agriculture. So the challenge persists in AutoML as well, because data quality, in the very first slide I have told the good quality of data, the good quality of model. So often noisy data is there. That time developing AutoML model is difficult. Data scarcity. This is the less amount of data is there. That time manually automatically designing machine learning model is difficult. High dimensionality. That is also high dimensionality of data is there. That time deploying the AutoML is difficult. So these are the challenges of AutoML. Computational and resource constraints, maybe there are some ethical consideration must be there. So now I will discuss I am now right now the last page of my lecture. I will discuss the emerging AI technologies in agriculture. So right now the advanced AI technology we can use for the AI for the agriculture. First of all, the Edge AI. Edge AI, why Edge AI will be used? The low latency, reduced cloud dependency, and real-time monitoring. These are the benefit of Edge AI. Federated learning. This is also a good direction for agriculture-related research. It is used for privacy preservation and scalable agricultural intelligence. AI, drone, and robotics. It will be used for spraying and monitoring, autonomous harvesting, digital twins. In very fast lecture, Professor Lal has given. He has discussed about digital twins, virtual simulation of agricultural environment, predictive crop management, and climate adaptation. Explainable AI, feature visualization. Which feature is contributing most for the output? That is the explainable AI. Some interpretable AI decision. The AI model generates the output, generates the classification accuracy or anything. That must be interpretable. the analysis is called explainable AI. And obviously, the multimodal AI, that is the most promising direction, most promising emerging AI direction for agriculture. Multimodal means more than one modality will be used. So, not only we will rely on the image, we are having image data as well as the sensor data from the soil, weather data, satellite data. We will consider more than one data together. That is called multimodal AI. So this is the most important modern direction for agriculture AI. So this is the future intelligent precision farming ecosystem. What I have told, drone or satellite monitoring from there, some IoT soil and weather sensors maybe there, edge devices that can be deployed in the rural area, in the field, cloud or federated AI platforms, real-time analytics, autonomous decision systems, and smart irrigation. These are the future intelligent farming ecosystem that can be utilized the advancement of AI. So these are the key benefits of precision farming, the smart agriculture. Mostly the real-time monitoring, continuous farm intelligence, predictive AI, smart resource use, autonomous farming, higher productivity, sustainability, data-driven decisions, and food security. This will lead to the sustainable agriculture. So lastly, towards the sustainable autonomous agriculture. So what can be the future direction of the sustainable autonomous agriculture? Firstly, autonomous crop monitoring. Secondly, self-optimizing irrigation. Thirdly, predictive disease prevention, climate adaptive farming, AI-driven resource allocation, and continuous farm intelligence. These are the future capabilities of towards the sustainable autonomous agriculture. And these are the expected impact. The impact of smart agriculture will be increased crop productivity, reduced pesticide uses, water conservation, lower operational cost, sustainable food production, and improved global food security. So, the convergence of AI, IoT, automation, and sustainable farming will define the next generation of smart agriculture. So, key takeaways throughout the lecture, throughout the last 1.5 hours, what we have discussed. AI enables data-driven agriculture, the motivation of AI for agriculture. After that, we have discussed the fundamentals of AI and deep learning, machine learning, deep learning, and after deep learning improves the agricultural intelligence. After that, advanced deep learning architecture like transformer and vision transformer to enhance contextual understanding. After that, we have learned AutoML, automated machine learning for intelligent model design. After that, precision agriculture that to support the sustainability and productivity. And finally, the intelligent agriculture represents the convergence of AI, automation, and sustainable farming. So these are the key takeaways from our this last 1.5 hour lecture. So thank you. If you have any questions, anybody have any question? The online participants, if you have any question, you can write it in the chat. Online participants, if you have any question, you can write it in the chat. And also the offline participants, if you have any question, you can ask or.
I have a question. So, if these systems go wrong, if these auto-ML systems, automated systems go wrong,
Take the mic.
then who is responsible for that?
Automated machine learning system.
If these systems go wrong at some point without human involvement, then who will
Okay,
be
that is the
responsible?
challenge of deploying AutoML. Therefore, a huge amount of data we must need. We need to train the model first.
That is,
Suppose you are building one automated machine learning model. Suppose automated CNN model you are building. The number of layers, the number of other hyperparameters. You have used the AutoML and you have defined this. If the system fails, the accuracy drops. That time, obviously, human intervention will be needed. But before applying the AutoML, therefore, we must ensure that we are using the privacy as well as the using the AutoML systems of criterions also is there. So you have to consider this first before directly deploying it in the rural or agricultural field. So first of all, you have to deploy the model. Any other question? So I think it is done. Thank you, everyone.
So with this, I would like to conclude this session by thanking Dr. Subhai for the highly informative and engaging session. Your lecture provided valuable insights in the transformative role of agriculture, modern agriculture systems through the lens of artificial intelligence and deep learning. You have highlighted the so many challenges involved and the emerging solutions uh, necessary for sustainable and efficient agricultural practices. Thank you once again. May we have a big round of applause for Dr. Shumai.
So we'll have one photo session, please.
So with this today's session is finished for it.
हर एक सेकंड का एक फोटो होगा कौन हाँ बोलिए सेम टाइम
So we'll meet again tomorrow for morning as per the schedule for the first lecture. Thank you for joining. Thank you.
रिकॉर्ड कर दीजिए
ऊपर है, ऊपर है.
स्टॉप